Alright, so now we continue with our example 15 here. Okay, so we are still under the part for calculating the mean and variance for continuous random variable, right? Okay, so if you look at this function now, they give you the function fx and the domain given is from 0 until 1. Okay, so first find the value of k. Again, this one you can do it yourself. K should be equals to 2. Secondly, they want you to show that the mean is equals to 0.75. So this one you can do it yourself also. Okay, so the third one, they want you to show that the standard deviation is 0.1936, correct to 4 significant figures. Alright, so to get the standard deviation, first you need to calculate the EX square first. Alright, so EX square means what? EX square means you integrate from 0 until 1, multiply the x square with the function. So the function is 3x power 2. Okay, then after that you're having a 3 and then x power 4. Okay, so if you continue with this integration, you should have the value which is 3 over 5. After that, you get the variance. So how to get the variance? Again, I skip the steps. You try to apply the formula yourself and get the answer. So the answer for variance is 0.0375. And after that, to get the standard deviation, you square root it. So when you square it, you should get 0.1936. Alright, so you can complete this one yourself also. And then after that, they're asking for this probability. They want you to get the probability from x minus mu until x plus mu. Mu plus sigma, mu minus sigma, and also mu plus sigma. That means mean minus standard deviation and mean plus standard deviation. So a lot of students, when they look at this one, right, they will thought that, oh, you need to change it become z. Actually, for this question, you cannot change it become z because this is not normal distribution. So it is still continuous random variable. What you need to do is you have to try to do the integration as well. Okay, so for the integration here again, because they already give you these two values, like although maybe your value for standard deviation is very long, but because in this particular question, they already tell you that sigma is 1936, therefore you can actually use the short value here. So you have 0.5 minus 0.1936, and then 0.75 plus 0.1936. And then from 3x squared dx. So this is what you need to do. So you have one value here, another value here, right? Okay. So again, carry out the integration. Try to get the answer 0.668. So again, for this question, you cannot change it become z because this is not normal distribution. If the probability density defined from A until B, and it has a symmetry line between the interval, excuse me, then the mean is the midpoint of the interval. So you see, this is a very important note that you need to know. Mean is the midpoint of the interval. Alright, so if you have a look for this question itself, example 16. Okay, so for example 16, if you look at it, right, you're having the function 1 over c. So c is a value, but what is that value you don't know. Okay, and then x is between 0 until c. Alright, so if you try to draw a figure, 1 over c means that maybe this is a value 1 over c, and then from 0 until c. So let's say this is a c. Okay, so from 0 until c, you have this one. Okay, and then this function has a line of symmetry, right? Because it is symmetrical at the midpoint here. Alright, so according to what we have just now, the midpoint is actually the EX. Okay, and because they ask you to state, so some students say, if I don't want to state, I apply the integration and get the answer, can or not? Can. Okay, but they will only give you the marks for the final answer. They won't give you marks for the integration and everything because they just ask you to state the value, state the answer. Okay, so this is how we apply the idea that I showed you just now. Okay, all right. Then after that, we go to part number 2. So for part number 2, they want to find the variance. Okay, so again, the same thing happened here. To find the variance, first, you need to find EX squared first. Okay, so if you apply the integration, your EX squared should be 1 over 3 C squared. Okay, and after that, only you find out the variance. So to find the variance, you apply the formula. The variance should be 1 over 12 C squared. Okay, and then after that, for part number 3, now they tell you that C is 6. So they want you to find the standard deviation of X. Also very, very simple. You just substitute the value of C into the variance and then try to take the square root. The standard deviation is 1.73. Okay, so again, I skip all the steps here, like the detailed steps. So you have to complete all the steps yourself and double check with the final answer that I provide you here. Okay, so this is what we have for example 16. Okay, then now let's have a look for example 17. Okay, so far for all the example that we tried, from example 1 until now, you can see that all the integration are very simple. That means they only involve the integration in AS level. All right, but for the recent years, right, they started to bring in all the integration for A2 level as well. If let's say they ask you the integration for A2 level, the simple case can be just ask you to integrate the sine, integrate the E, integrate the ln, integrate the E, and also integrate the sine, trigo, all those things. If let's say they want to really test you the hard question, they will also introduce integration by part in your A2 syllabus. So integration by part, your step will be quite long. All right, so I believe that most of you haven't learned it yet for now. So when you go for your pure maths class, right, when you learn integration by part, so please pay more attention in that. All right, so it is an integration technique that is quite long. So previously there are some questions involve integration by part in statistics also. So please make sure that you can you link all the techniques and everything together here. Right? Okay, so let's have a look for example 17. So this is one example that they involve the P3 integration method. Yeah, so for this example, it is still easy because they just ask you to integrate E power, which is a basic one or easy one. So I believe that again, maybe some of you haven't learned how to integrate the E. I will just show you the basic here. And then when you learn it in paper 3, okay, your integration chapter, then please pay attention for this. All right. Okay, so first, they give you a function like this. So they want you to show that k equals to 1 over 5 e minus 1. Okay, and then here the domain given is from 0 until 5. Okay, so I'm going to start now. Okay, so to show that k is equals to this value, generally I need to do the integration from 0 until 5 for my basic equation here, my basic function here, and I will let it equals to 1. Okay, so k is a constant, I just copy. Okay, so we want to integrate e power 0.2t, right? The method is something like this. When you have e power anything with x or with t, then you just copy back the original thing, divided by, you differentiate the power. Differentiate the power, you get 0.2, right? So you divided by 0.2. I believe that you learn differentiation, right, for e. So differentiation for e means that you copy the original thing, then you multiply the differentiation of the bracket. So integration is the other way around. You copy also the original thing, then you differentiate the power, but you divided the power, the differentiation of the power. Differentiation is multiplied. So for integration is divided. So it is opposite way. Okay? And then you substitute the value 5 and 0 and you let it equals to 1. Okay. So now you start to put in the 5 and put in the 0 into the t. So 0.2 is a constant. I prefer to take it out. Okay, so substitute 5, you get 1 minus e power 0, and it is equals to 1. Okay, then after that, k equals to, so you're having 0.2, okay, divided by e power 1 minus 1. Okay, so please take note that this e power 0 here is a 1. So this bracket bring it down, become e power 1 minus 1. Okay, 0.2, if you change it become friend, then you will get 1 over 5 e power 1 minus 1. So this is how you show that the k is equals to this value. Alright, and then again, the integration that involved in this example is actually the integration technique in A2 syllabus. Okay, so far what we tried before is all the AS syllabus one. So now I introduce one method here, one example here that involves the A2 syllabus one. And this is an easy A2 syllabus. Alright, so if they really want to test, they can ask for the hard one, which is the integration by a hard technique, a long technique for integration. Okay, then now let's continue to part number 2. They want you to sketch the probability density function. So how can you sketch K E 0.2? Right? Okay, so generally you need to know how to sketch the ET first. So to sketch an ET, your E graph is something like this. Okay, you learn it in chapter 2, pure maths. Alright, so because my domain is from 0 until 5, right? So my ET will look something like this. It will pass through the 1. Okay, and then after that, when I have E 0.2t, generally it is still the same. Okay, just that it become not so steep anymore. But the value is still the same, the shape is still the same. And after that, when you try to multiply k, okay, so when you multiply the k, the value 1 here, you also need to multiply the k, therefore it becomes k already, and then the graph will look something like this. Okay, so we are applying the transformation of graph technique that we learned in AS level before. Okay, so I know that roughly my graph will look something like this, start from k until a certain value. So I will just sketch it roughly. Okay, so when I sketch it, it will look like this. Right, so this is a k, and then my graph will look something like this. So this is power, this is value of 5, and then 0. Okay, so this is t, this is ft. Alright, so this is how we sketch the graph. So again, you will see that you actually need to memorize the graph for ex, or maybe e negative x, and so on. Okay, alright, then here they say 80% of fireworks burn for longer than a certain time before they explode. So find this time. Okay, so here, when the firework burns for longer than a certain time, that means if your T more than a certain time, right, so greater than a T, okay, it is equals to 0.80. So that's the meaning. Okay, burns for longer than a certain time. Longer means greater than. A certain time means T that you don't know, and you want to find the T, and the probability is equals to 0.8. Okay, so now how to find out the probability for T greater than T? So again, you need to do the integration. Start from T, the limit, and then until the highest limit 5. And the function that you have is K E 0.2T. And it is equals to 0.8. So for me, I just write it out as K because to me this is very complicated. So I just write it as K first. At the last step, only I try to substitute it. Okay, so again, K is a constant. I just copy. How to integrate e power 0.2t? Again, copy the whole function here, e power 0.2t divided by the differentiation of the power 0.2. And you substitute 5 and t equals 0.8. Okay, alright, so if you bring, okay, so if you try to bring out the 0.2 and multiply it with k, okay, generally you have 1. Okay, you just substitute the value of k by this, and you multiply with 0.2. Then generally you have 1 over e minus 1. Then e 0.2t 5 and 8 equals to 0.8. Okay, then now you want to substitute the 5 inside and also substitute the t inside. So you have e power 1 minus e power t equals to 0.8 multiplied with e power 1 minus 1. Sorry, there's an error here. So this one should be 0.2t. Okay, so if you bring it to the other side, you have 0.2t equals to e power 1 minus 0.8 bracket e 1 minus 1. Okay, and after that you have to take the ln. So when you take ln both sides, you have 0.2t equals to ln, and then e1 minus 0.8 e1 minus 1. So when you press calculator, please be careful on all these parts here. Alright, and then you try to bring the 0.2 over, you will get the value 1.48 for the t. So you'll see that this one will be a bit more complicated, and then throughout the solution, right, you actually need to know how to ln, how to bring over all the value correctly, and then only you can get the value of t. So besides the integration, you also need to have some very basic idea on how to solve the equation that involve the e. Okay, so this is what we have for example 17. One of the examples that involve A2 integration technique. This is not the only one, we have more, but I will just try to keep it for you until you learn your integration in A2 level. Alright, so this is what we have our continuous random variable. And then you will see that it actually, the whole chapter, they are talking about integration. Alright, so of course your integration technique need to be quite good so that you can get the answer correctly. Alright, so we already ended our chapter 3. So again, next video we'll start with another new chapter, which is the chapter 4. Right, so we'll see in the next video.